So this example is entitled a power of a power rule. Also is going to have us do a negative exponent thing again, just to make sure that we don't forget how to handle a negative exponent. But in this problem, it's very short, very self-contained. And the question is, how do we take a power of a power? If I want to raise, in this example, w to the fifth to the power -4, then what should I do with the exponents instead? How do we trade the arithmetic of powers for an arithmetic operation in the exponent instead? So the strategy here, as usual, is going to be to find the powers. Where are they? And then to move the power arithmetic that we want into exponent arithmetic instead. Same arithmetic layer cake. We know at this point that to add or subtract exponents, we do that when we multiply or divide powers, respectively. But if we go one step higher on this cake, we'll see that in order to raise a power to a power, that's the power operation on the top layer of the cake, what we're going to do to the exponents instead is multiplication. So the power here is w to the fifth. But then we're taking that power and we're raising it to another power, to the -4th power in this example. So what's it going to mean? Well, exponentiating a power, according to our arithmetic layer cake, is the same as multiplying its exponent. So w to the fifth raised to the power -4, if we take that operation being done to the power, namely w to the fifth to the power -4, and we elevate that arithmetic up into the exponent, upstairs on the exponent, it becomes a multiplication sign. So instead of seeing this as w to the fifth to the power -4, we can instead see it as a single power of w, namely w to the power 5 times -4. 5 times -4 is -20. And so in total, when we've done all the arithmetic to the exponent that we can do here, we have -20 powers of w in our final answer to this problem, which is great. So that's the tricky step. That's the new step, right? To raise a power to a power, multiply the exponents by one another. Of course, we're not done because we need to write our answer without using negative exponents according to the statement of the problem. So we again just need to trade negative exponents for positive exponents, and we can do that by trading multiplication of that power for division by that power. But there is no multiplication sign here. Well, let's put one in there and see, again, a hidden coefficient of 1 sitting in front of w to the -20 power. So now we are able to say that instead of multiplying by that power having a negative exponent, we can turn the exponent positive by dividing in by it instead. So what we really have is 1 divided by w to the +20 power, which again, getting rid of that archaic division symbol and making it a fraction, what we really have is 1 over w to the 20th. So how do you take a power of a power? Multiply the exponents. In this example, we also had the one additional step of turning the negative exponent in the answer back to positive, which we did the same way that we always do by dropping it into a denominator or moving it from a denominator up to a numerator, functionally just swapping out what used to be multiplication for division, or if the situation warrants, do it the other way around.